Okay, this is the Unit 6, video number 5, phase changes. So prior to this video, we were talking about specific heat, and what specific heat is how much energy is it going to take to raise a certain amount of the substance from an initial temperature to a final temperature. When we're dealing with phase changes, we've already reached the phase change point. So we've already reached the boiling point temperature, we've already reached the freezing point, the melting point, and so on, and the vapor point. So what we're going to be interested in is how much energy is going to be necessary to change the phase. So to change from a solid to a liquid or a liquid to a solid. So we're going to have 3 different types of variables that we're going to represent when we're doing phase changes. The first one is going to be called the heat of vaporization, which we're going to represent as delta H of vape, is how we're going to abbreviate it. Then we're going to have heat of fusion, which heat of vaporization obviously is going from a liquid to a gas state. Heat of fusion is going to be delta H. What fusion represents is melting. So we're going from a solid to a liquid here. And then sublimation, obviously we skip the liquid phase, so we go directly from a solid to a gas. Now, what if we were to reverse those reactions? So let's say instead of melting, so instead of going from a solid to a liquid, we want to freeze. We want to go from a liquid to a solid. The way we would do that is we would just take the negative value of each of these variables. So here, if we're condensing, it would be the negative delta H of vaporization. If we're freezing, it would be the negative delta H of fusion. Okay, and if we're going to do deposition, which is the opposite of sublimation, it's going to be the negative delta H of sublimation. Okay, and if you're never given the delta H of sublimation, but you're given the delta H of vaporization and the delta H of fusion, we can add those two together, and that's always going to equal our delta H of sublimation. Okay, so let's go through real fast, and let's do some problems to represent phase changes. So we're going to have an equation that's going to represent phase changes, and it's going to be Q of whatever we're solving for. So let's say we want to know what the Q of fusion is. Then we would say it's the Q of fusion. We would say it'd be equal to our delta H value of whatever that is. So maybe we're melting. So let's go ahead and say we're melting. So the Q of fusion, and it's going to be times N. So times our number of moles. Okay, if our delta H value is in gram, then we can use gram. It doesn't have to be in mole. Okay, but for here, the problems are going to be in mole, so we need to keep it in mole. So here it's saying, what is the mass of water present if 26.4 kilojoules is necessary to boil it once it is at 100 degrees Celsius? So the key here is we're not changing temperature. We've already reached an initial final temperature. Not doing any changing here. Now we're just going to phase change. So what I gave you here is your Q of vaporization, because we're boiling, so we're going from the liquid to the gas state. Okay, and I want to know what is the mass. So I don't know mass, but I can get moles. Okay, and I gave you your delta H of vaporization right here. Your delta H of vaporization is 40.67 kilojoules per mole. So if we were to plug all of this in, we're going to get 26.4 kilojoules equals my delta H of vaporization, which is 40.67. I use vaporization because I'm boiling right here. So 40.67 kilojoules per mole. Okay, and we're going to solve for our number of moles because that's what we need in order to get to mass. So if you were to punch all of this into your calculator, you get that N is going to equal 0.649 moles. Okay, and now we know that we know easy calculation from mole to mass, so we can go ahead and convert this to mass of water. So moles is going to go on the bottom. We're going to have 1 mole. The mass of water is 18.02 grams. If we multiply this across, we'll end up getting that the mass will equal 11.7 grams. So what this is saying is that in order to phase change water, so to change water from the liquid state to the gas state, to boil it, it's going to take 26.4 kilojoules only to boil 11.7 grams, which isn't a lot because we know water has a very high specific heat. Okay, the next one here, it says, what is the heat of fusion if if 11.5 kilojoules will melt 500 grams once it's at its melting point? Okay, so once again, temperature is not involved here. We've reached a certain temperature. So we're going to use heat of fusion. So we know our equation is going to be K of fusion equals a delta H of fusion times the number of moles. Okay, so here, what I gave you in the problem is I gave you 11.5 kilojoules, so this is my Q. Okay, this is my heat. Melt 50 grams. I gave you your mass, but we know that if we have mass, we can convert that to grams. Okay, so, and to solve for our delta H of fusion. So we've got Q, we've got N, so let's go ahead and convert this into into moles. So we've got 50.0 grams of lead. Okay, and we know to convert this, we're going to get the mass of lead on the bottom. Lead is 207.20 is to 1 mole. And we get that the moles of lead is 2.41. Okay, now we can take this and plug it into our equation. So our Q of fusion was given to us, it's 11.5 kilojoules. So we're going to take 11.5 kilojoules equals our delta H of fusion, which is 2, which we don't know, I'm sorry, that's what we're solving for, times the number of moles, which is 2.41 moles. Okay, so to solve for delta H, you're going to divide by 2.41, and we're going to get that our delta H of fusion is going to be equal to 4.77 kilojoules per mole. Okay, it's very important when we're doing phase change and specific heat calculations, so you're paying attention to the units. The units must match. If it's in kilojoules, it needs to stay in kilojoules. If it's in joules, you need to make sure your end answer is also in joules.